Good morning. So in this video, we will be discussing the maximum and minimum values. But before that, let's first recall about critical points. Remember class atong previous discussion when we say critical points, for example, this is our graph. Kani man sila no, ang mga critical points nato kung kano sa siya ni saka o kano sa siya ni naog. Diha na dayon mo gawa si maximum and minimum. Now, we will do the same here. Pero, we will be using the function nga x, y, z. Okay? Now, let's have the definition. Definition of critical points. Okay. So, let z be equal to f of xy. Be a function of two variables that is differentiable on an open set containing the point x sub o, y sub o. The point x sub o, y sub o is called the critical point of functions of two variables. Now, however, class, before ni si x sub o and y sub o will be considered as critical points, dapat naasa siya masatisfy na conditions. However, take note nga one of the following two conditions lang. Not necessary nga sila duha. And I think dili pud ni siya mosabay nga conditions nga sila giduha nag-exist. Why? So sa number 1 na condition, we have the first derivative of f with respect to x is equal to the first derivative of y with respect to x. And both of them must be equal to 0. Now, sa number 2 class, take note nga either si f sub x or y sub y does not exist. Now, if one of them does not exist, dili pwede nga mag-equal na sila. In other words, again, only one of these will be needed. At least isa ra, pangitaon na ninyo diha. Asa ang mo satisfy. Okay? So, if you will get one of the derivatives, tapos ang isa wala nag-exist, critical point na to siya. Or, if ever nga nag-exist ang duha ka derivatives at x sub o, y sub o, dapat equal sila. Now, suppose, let's have, find the critical points of each of the following. So, we have here f of x. Adrita sa B class kay nakaradical ning A. G of xy is equal to x squared plus 2xy minus 4y squared plus 4x minus 6y plus 4. Okay. Dita. So first, we calculate the first derivative for both x and y. So kani sila ang first derivatives. Then, we take the value kung unsay maka-0 sa ato ang f of x and y of x. Now, since duha man ito equation class, we can use the elimination method or the substitution method. Now, in this, ang iyang gigamit is elimination. So, mag-multiply kung negative dire. Negative times positive is negative. Negative, negative is positive. Negative, negative is positive. So, I will have 0 ang x, 10y plus 10 equals 0. Transpose, I will have y, 10y is equal to negative 10. You will get 1. Now, Substituting si y gikan sa ato ang equations from either equation 1 or 2 since ang giingon sa condition kay equal man sila. Substituting that, you will have x is negative 1. So we have the critical point of G is negative 1, negative 1. Okay. Now take note po class, since wala man ta dire x and y values nga maka 0 sa both atong equations, we cannot use the second condition nga one of them does not exist. So dito sa number 2 class, ang ato lang gigamit kay si number 1. We cannot use number 2. And if we cannot use number 1, dapat si number 2 ato ang gamiton. And si number 2 will only be used if naa kay value sa imong x and sa imong y where the critical points nimo does not exist. Now let's have the global and local extrema. So let's have the definition first. Let z be equal to f of xy, a function of two variables that is defined and continuous on an open set containing the point x sub o, y sub o. Then, f has a local maximum if your f of x sub o, y sub o is greater than or equal to xy. Kaning f of xy class, kaning xy ninyo diha, any point na siya for, and kaning inyuhang f of x sub o, y sub o is your center sa inyuhang disk. Again, kaning siya is any point in your disk. Sagahan na siya diha. Pero kaning x sub o, y sub o will only be the center. The number f of x sub o, y sub o is called the local maximum value. And if the preceding inequality holds, kung ma-okay daw ni, if this is true, for every point x, y, then f has a global maximum at x sub o, y sub o. To put it simply class, if ever true ni siya later, natay center sa disk nga f of x sub o, y sub o, and any point, bisag aha ka diri mo kuha, and true siya, we can say that si center is the global maximum. Si global minimum pod class, same ra gyapon, pero ang kalahian lang nila is dapat mas gamay na tong other points compare sa mas dako na ang other points compare sa inyong center sa disk. Okay? Now, if ever ang inyong f of x sub o, y sub o class is a local maximum or local minimum, gitawag raton na siya og local extremum. Kanus ani si local extremum? If ever nag-exist si global maximum or minimum. Okay? Kung naa siya global maximum or minimum, we can call it in general as local extremum. Now, let's have the Fermat's theorem. Let f of xy be a function of two variables, and it is continuous on an open set containing the point x sub o. Now, suppose nag-exist daw diha ang inyong first derivative for x and y. If f is has a local extremum, na daw to local, no? So, less than, then critical point pud siya ni f. So, unsay kalahian ani nila class? Unsay kalahian ani nila? We have nag-start na ka diri sa imuhang ang sa kanin sa theorem class, iyahan ang gi-assume daan nga local extremum na ni sa x sub o y sub o, dayon giayha pa niya then critical point siya. Sa preview sa definition nato, critical point siya, then matawag siya og local extremum or extremum. So gibali lang diri sa theorem. In other words, pwede ra it will work either way. Kung naa na kay local extremum, then naa na kay critical point. If mag-start po ka og critical point, then naa na po kay local extremum. Okay? Now let's proceed to the second derivative test. The second derivative test class will be used sa inyuhang as your saddle point. Okay? Now, given the function f of xy and the point x sub o, y sub o, and your z diha, if both the first derivative of f and with respect to x and first derivative of y with respect to y, if they are both 0 then but does not have a local extremum, then we can say nga saddle point siya. Kano sa si saddle point nag-exist after getting the derivative, tapos both si x and y kay mo yield og 0 na result, pero wala siya local extremum. So wala max or minimum, no? Then we can say nga that point f of x sub o, y sub o is a saddle point. Okay? Now, let's have the second derivative test. Now, let z be a function of two variables for which the first and second order partial derivatives are continuous. And suppose the first derivative of x and first derivative with respect to y are both 0. Then, we have here the second derivative of f times the second of f with respect to x times the second derivative of f with respect to y minus f of xy at 0.00 raised to 2. Okay, so dirigi ka na itong d. If si d daw nato is greater than 0, and if multiply nimo ang product sa x, if you will get the derivative of x twice, and equal to 0 ra gihapon siya, you will get the local minimum. If si d nimo is greater than 0, dayon ang iyang second derivative is less than 0, then naa siya local maximum at x sub o, y sub o. If less than 0 si d, naa siya saddle point at x sub o, y sub o. Then, lastly, if d is equal to 0, then the test is inconclusive. In other words, wala tay specific result nga makuha. So, if ever mag-0 inyong D class, you may not continue. You are done. Walay conclusion. Okay. Now, suppose we'll try to find the critical points for the following functions using the second derivative test. Now, let's have letter A. Now, first derivative is 8x plus 8 sa x, and first derivative sa y is 18y minus 36. We'll both equate them to 0 and get the value. So, first diri is, sa value ni y, negative 1. If y is negative 1, x is negative 1 and our y is 2. That's why we have this. Then, atong critical point is negative 1, 2. After getting the critical point, class, you now proceed to step 2, which is CD. So, pag-calculate kang D, class, we have the double derivative, the second derivative for x and y. And we get the second derivative, ani? Instead na 8x, you will only have 8. Kang y, instead na 18y minus 36, you will only have 18. Okay. Now, since both of them, the f of xy is 0, dire, we can have 0 pud sa ilahang points. Okay? Pero kaning naka-0 sa inyong points, class, take note na they are the points, naka-0 sa inyong function, they are the points negative 1, 2. So, we'll have kanipod si negative 1, 2, maka-0 po na sa inyong f of x. Direct substitution, we have 144. After makuha ninyo si D, check na dayon ta if D is greater than 0 or less than 0. Na 144 is greater than 0, balik na kadali sa condition. Greater than 0, so naara ta sa first I and second I. Check na to ang first derivative is less than 0 or greater than 0. Then diha na dayon mag-determine if maximum siya or minimum. Okay. Now, since greater than 0, let's check. Ang value sa negative 1, 2 sa first derivative as second derivative is greater than 0. Now, this corresponds to the first I nato. In other words, negative 1, 2 is our local minimum. Okay? So, that is how we find the local maximum or minimum. So, nara tayo 3 steps diha, no? Okay. Now, let's have the absolute maxima and minima. Now, suppose we'll have a continuous function in a closed bounded set. In a plane attains an absolute maximum at the value at some point and absolute minimum value at some point D. So, in other words, kung naatay continuous function and a closed and bounded set D, naagid tayo maximum and minimum ang absolute points. Now, how do we find them? Si maximum nga, si absolute maximum, absolute minimum, class, they are also called the extreme values. Now, assume we have Z is differentiable function of two variables defined in a closed bounded set D. Then F will attain the absolute maximum and the absolute minimum, which are respectively largest and the smallest value found among the following. First, the value of F at the critical points of F in D, and the values of F on the boundary of D. Okay. Now, how do we do that? First, we determine the critical points. After that, calculate F at critical points. Determine the maximum and minimum values. Next, the maximum minimum values of F will occur at one of the values nga itong makita sa steps 2 and 3. Okay? Now, Okay, so let's now have this example. Now we will try to find the absolute extrema. So let's solve letter A. And our domain here is from 0 to 4 for your x and 0 to 2 for your y. Your function is x squared minus 2xy plus 4y squared minus 4x minus 24 plus 24. Ito, class, whenever you see this, this is equal to f of x times f of y in y. Now, let's have the first step, which will try to find the critical points. So after finding the critical points, class, we have the first derivatives for both x and y, and then we will try to find what makes them 0. Now, sa inyong first derivative, class, kung napagali mabilin nga x plus y kintahay equals 3, tapos sa pikas na apay mabilin pod, that is when you do the elimination method or substitution. If ever ang mabilin sa inyo is only x and y, pareha sa atong previous example, x ra kintahay, x plus 2 equals 0, ang isa y plus equals 0. Kung yun ani ra, dili na mo kinahanglan mag-elimination ani. Mag-elimination ra mo kung naapa mo 2 variables nga nabilin for every equation. Okay? Now, let's proceed further. After getting sa inyuhang critical points, which is 3 and 1 sa dire, let's now proceed to the second step. Now, sa inyuhang graph, class, this is what it looks like. Mo ni inyuhang domain. Okay? So, kana ang inyuhang image. Now, this time, we need to find the critical, kung aha siya nag-maximum or minimum. Balik tagamay ha. So, naa naman tayo critical points, no? We'll now determine the maximum and minimum values niya. So, sa iyang maximum minimum values, class, gamiton ra gihapon nato dito si t, which is 0 to 4 and 0 to 2. Okay. So, sa kani class, this is direct substitution sa atong values. So, naaragapon mo number line ani sa inyong f and x. Balik tagamay ha. So, ang y nato dire is 1, ang x is 3. Ang y, ang x nato 3. So, kuha ta dire both sides. We have 0 and 2. Except sa kani, kay gusto man ta makabalo kung maximum or minimum siya. So, that's why we have 0, 2 dire. Ang kani, 3 man natong x, we can go further, dire sa right. Ang iyang gikuha is 4. And dire, since minimum man ang, easiest man ang 0, that's why 0 ang iyang gi-pair. You can also use 2, 1, negative 3, negative 4. Okay? Now take note, class, nga ang inyong value, nag-maximum siya at 36. Kaning 36, nagikan. When your x is 0, so naa dire, na side. When your x is 0 and your y is 2. So, in other words, nag-maximum siya at 0, 2. Next. Global minimum is 20. Siya na nakakuha 20. 4, 2. So, in other words, our global minimum is 20. Now, you might ask me, what if lahi akong value nga ibutang diha? Then, you will get a different result, pero you can still determine kung nag-maximum ba siya diha or nag-minimum. Okay. So, I think that would be all for this topic. In our next video, we will have the Lagrange multipliers.